طيب بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه ومن والاه. Any questions before we proceed? Any questions before we proceed? طيب. So what we will do today, عليكم السلام ورحمة الله, is we will look at counting. We will look at counting. This is from chapter 6. Okay, this is from chapter 6. So basically, we will take the first four sections, section 1, 2, 3, and 4. Now, let's come to the motivation. Why do we study counting? Well, as it turns out, combinatorial questions arose in the study of gambling games. They were very much interested in gambling. ولسه بتشابتر 7 راح تشوفوا لعب الشد يعني برمضان، وراح نقعد نعلمكم هالاشياء. لا حول ولا قوه الا بالله. طيب. So of course يعني it's not the fools who put their money and gamble are the ones that use probability and counting. It's the owners of these casinos. Yeah, because they want to maximize their profits by fooling the public. But anyways, not only that, but counting, or basically enumeration. What is enumeration? It's basically the counting of objects with certain properties. The counting of objects with certain properties is an important part of combinatorics. This is, by the way, called combinatorics. Okay. For example, counting is used to determine the complexity of algorithms. We will not go into much details here, but we will see, for example, an example today where I will give you a piece of code and I will ask you, well, how many times this line is executed? This is in the heart of complexity analysis. And of course, you will take more if you take the design and analysis of algorithms course, ICS 353, but you will have a sense of it here. Okay. Counting is also required to determine whether there are enough telephone numbers and internet protocol addresses to meet demand. Remember a few years ago when the number 1 was added to all the area codes of the cities in Saudi Arabia? We used to be 03, now we became 013. Why is that? Well, because of the population, because the cities are getting larger, there is a need for more phone numbers. There is a need for more, those local area codes. It's very important, counting will help you determine, for example, for a certain numbering system, how many telephone numbers can you have? In fact, you will have to know how to do that, right? Also, counting techniques are extensively used when probabilities of events are computed. Again, inshallah, we will see that in chapter 7, okay? We will see that when we talk about discrete probability. Finally, do you remember the video that I shared with you regarding Fermat's last theorem, the proof by Andrew Wiles? The heart of that proof is actually using counting. He basically did an enumeration. I think he employed counting between what was it? Modular forms and elliptic curves, right? In fact, we did it in chapter 2. We did enumeration. Do you remember when we proved that the positive rational numbers have the same cardinality as z plus? What did we do? We enumerated the rational numbers. صح? We developed an enumeration of the rational numbers, and it turns out it has the same cardinality as z plus. So counting is very important, okay? And what we will study here is in section 1, basics of counting. This is what we will start today. Then we will look at the pigeonhole principle in section 2, section 3, permutations and combinations, and finally section 4, binomial coefficients. Now, let me make a very strong warning. You cannot imagine how easy it is to make mistakes, especially in the first 3 sections. Okay, especially in the first 3 sections. And I think, although we are going to take only one rule today, you will see a preview of that. Okay, you will see a preview of that. So, what is the best way to respond to this? You have to answer all odd-numbered exercises that are related to the material that is given. You cannot escape practicing, on your own, especially before exams. You don't want that practice to happen in the exams. Okay, you really have to practice. You really have to have confidence. When you look at a question, not only you need to understand it and then know how to solve it. Which rule are you going to use? Okay. Anyways, I'm not going to speak more. Let the material speak for itself in just a few minutes. Okay? Bye. It has no connection. هلا راح تشوف. No, now you will see. Now you will see. طيب. So let us consider the first rule, which is the product rule. So what is the product rule? Well, suppose that a procedure can be broken into 2 tasks. A procedure can be broken into 2. You can accomplish this procedure by carrying out 2 tasks. Now, if there are n1 ways to do the first task, and then there are n2 ways to do each of the tasks of the first task. So each of those n1 ways of doing the first task, each one of them, there are n2 ways to do the second task. Then the product rule says that there are n1 times n2 ways to do the whole procedure. Okay, there are n1 times n2 ways to do the whole procedure. Let's take examples. Hopefully the concept will become a little bit clearer. So let's assume that there are 32 microcomputers in a computer center. You notice that the wording of this exercise is like 20 years old. 20 or 30 years old. Anyways, each microcomputer has 24 ports. How many different ports to a microcomputer do we have? 32 multiplied by 24. So we have basically 32 multiplied by 24. So what are the 2? What is our procedure in this case? Well, our procedure consists of 2 tasks. The first one is determining the microcomputer, right? Or choosing a microcomputer. How many ways can we choose a microcomputer? 32, صح? And once you choose one, the other task is to determine the port. How many ways are there for the port? 24 ports. It's a very straightforward application of the product rule. Okay? Fine. Let's go to the second example. How many different bit strings of length 7 are there? Yes? 2 to the power of 7. Is that correct? 2 to the power 6. Huh? 2 times 2, 7 times, right? So here, my procedure has how many tasks? My procedure has 7 tasks, not 2 tasks. صح? Has 7 tasks. So basically, what do I have in this case? Well, since I have 7 bits, since I have 7 bits, let's say B1, B2, B7, right? Where each bit can have values, a value from 0 or 1. Let's put it in a set from 0 or 1. So I have basically 7 tasks, right? First of all, for each bit from between 1 and 7, I have basically 2 possibilities, right? So therefore, the total number of bit strings, of course, different bit strings of length 7 is equal to 2 to the power 7. Okay, is equal to 2 to the power 7. طيب. Okay, this is a good question. And I will give you 2 minutes to try to answer this question. How many functions are there from a set with m elements to a set with n elements? No, think about it. I'll give you 2 minutes. Don't rush. Talk to your neighbor, do whatever you want to do, okay? Do whatever you want to do. But please try to solve it. Try to solve this. How many functions are there from a set with m elements to a set with n elements? Yeah, I'll give you 2 minutes. Sip my tea while... No, think. I'll take all your answers, don't worry. Is this a question? What's the question? How many functions? What is the definition of a function, ya shabab? What's the definition of a function? It's basically you assign each element in the domain exactly one element from the codomain, صح? Something like that. Okay, that's the definition of a function. How many different functions can you create? That's the question. يلا يا شباب ها وراح let me start the 2 minutes from now. I'll remove the كان باقي هلا 1 minute. ها شلناها. We're starting the 2 minutes from now. Write it down, okay? Write it down, and I will take your answers. I'll take all your answers. Don't worry. Huh? M is the number of elements in the domain, and n is the number of elements in the codomain. Yes, exactly. Yep. A question? No, the function is only from the domain to the codomain, بس. It's not the other way around. مش لازم يكون لا on to ولا 1 to 1. Did I make any restriction? Did I make any restriction على الفانكشن انه 1 to 1 ولا on to? I did not make any restriction. طيب. So the time is over. So let us now move on. I hope that the voice is still working. Let me just make sure that. Yes, okay. Very good. طيب. Okay, so that you don't feel left out, I want to make sure that you do not feel left out. I will take all your answers. No answer will not be counted. All answers are counted. يلا يا شباب هاتوا نشوف. Go ahead. ها؟ M. There are M functions. طيب غيره. N to the power M. غيره. N. So this is A, B, C. أيوة.
2 to the power m multiply n.
2 to the power M times N on the power صح؟ حلو. غيره. Any different answer from these? Yes.
You have 2 to the power of n or m to the power of n.
Say that again.
I have 2.
You have two answers.
The first one is n to the power of n, and the m to the power of n.
And M to the power of N. M to the power of N, like this. طيب.
m multiplied by n.
M multiplied by N. Yes.
The addition of B and E.
The addition of
B and E.
B and E. So N to the power M. N to the power M plus M to the power N. صح؟ غيره. Yes.
M plus n factorial.
M plus N.
Factorial.
كلها factorial between brackets. M plus N factorial. طيب. Those who say that the answer is A, please raise your hands. 1, 2, 3. So I have 3 here. Those who say it's B. 1, 2, 3, 4. Okay, so I have 4. Those who say it is C. 1. D. 3. E. 1. F. 2, 3, 4. 4. 4. طيب G. 1. And H. 1, 2, 3. طيب. Yes.
I have another one.
You have another answer? يلا هات نشوف.
M plus N.
ها؟
M plus N.
M plus N. تمام. كمان
2 في M في N.
2mn like this. H, I, J. And we have at least one here and one here. Do you see this? This is what will happen to you in the final exam when I do the counting. And the funny thing is, you will see all the possible answers in all the choices.
T.
You will see all the, and in fact, because now I have F, G, H, I'm thinking of even some questions in the final exam to have more than 5 choices. So that I can cater for everybody in the ICS 25. Okay? Wallahi, this is what will happen if you really do not practice. If you do not practice this, what will happen? You will come out of the exam, you will think you aced it, and then, the big shock will happen. Although it's multiple choice, يعني المفروض تكون easy. طيب. So, by the way, the right answer is B, n to the power m. Now, let us see why it is the right answer. In fact, it's funny, I'm not going to write it for this one. I'm going to write it for the next question. But let me say, mention why it is n to the power. Why it is n to the power m. I want to count the number of different functions. Right. Let's take the first element in the domain. How many possible images does the first element has? Has n possible images. Right. So this is the first task. Now I need to assign the second element. How many possible images exist for the second element? Again, n dash n minus 1. And I didn't say it is 1 to 1. But yep, I did not say it is 1 to 1. The second element has also n possible images. But the third element, n possible element, up to the mth element, n possible. So in total, how many different functions can I have? Well, it is n times n times n m times. So that's why it is n to the power. That's why it is n to the power m. Okay? That's why it is n to the power m. Right. The details, by the way, this is an example in the book. You can actually check the details in the book. But I will write the details for the next question. The next question is exactly the same, but now it's asking for one-to-one functions. So now it's not without any restriction. Now I'm making a restriction that I need to count how many one-to-one functions exist from a set with m elements to a set with n elements. Shall I give you 1 minute? You are ready to say some answers? n factorial. n factorial, you are having a hidden assumption here. You are having a hidden assumption. I'll come to your answer later on. Anybody has any other answer? Huh? M? No.
M multiplied by n.
M multiplied by n. Yeah, Shabab, you need to think in exactly the same way. You need to think. In fact, I gave a hint in my answer to the previous question. And I thought that you will say it directly. Yes?
M times n factorial.
M times n factorial. كمان لا. يا شباب, you need to use the logic of the answer.
دكتور نبدا من m اول m له n فاكتوريال اول m له n possibilities ثاني m له n minus 1
مش اول m وثاني m. You mean the first element and the second element from the domain, صح؟ طيب. So since and there is a reason why I'm starting from here, because I will fill that later. طيب. Since the first element in the domain has n possible images, comma, the second element in the domain has has n minus 1, صح? Has n minus 1 possible images. طيب. What about the third? Has n minus 2 possible images. طيب. If I continue until I reach the mth element in the domain, has how many? n minus between brackets m minus 1 صح؟ this is easy يا شباب. I mean you just need to look at the pattern صح؟ the first element has n minus 0. The second element has n minus 1. The third has n minus 2. The fourth has n minus 3. So the mth has n minus between brackets m minus 1. Right? Which is equal to, by the way, this is the same as n minus m plus 1 صح؟ n minus m plus 1. طيب, using the product rule, the total number of of one-to-one functions from a set with m elements to a set with n elements equals what? Huh? Equals n times n minus 1 times n minus 2 all the way until n minus m plus 1. N minus m plus 1. Can anybody give me this number in terms of the factorials? What does this equal in terms of the factorials?
n factorial minus n minus m.
لا. Yes.
n factorial is over n minus m factorial.
أيوة. This is equal n factorial divided by n minus m factorial. Divided by n minus m factorial. Do you understand how did we get this number? No?
No. The last thing.
Which one? أول شيء هذا n في n minus 1 up to n minus m plus 1. Is that clear?
Yes, I'm confused. But how did we get n minus m minus 1?
لأنه the first element, element 1, has n possible images. طيب, element 2 has ايش؟ n minus 2 ولا n minus 1؟
No, it's minus 1.
n minus 1. طب element 3
So m minus
has n minus 2 صح؟
Yeah.
معناته element m has n minus between brackets m minus 1. Just the pattern matching صح؟ طيب. اوكي واضح يا شباب؟ طيب. يس.
هذه ما كنت أعرف.
طيب.
ليش خلينا فاكتوريال على n؟
هلا هذا n times n minus 1 times n minus 2 all the way up to n minus m plus 1 صح؟
إيه تمام.
طيب to continue n factorial مش I need to multiply by n minus m factorial. ايش اللي بعد ال n minus m plus 1؟ less by 1 is how much؟ n minus m. طيب n minus m factorial if I multiply by n minus m factorial مش هذا كله اللي فوق صار n factorial؟ شو؟
خلاص براجع.
لا ما حنطلع ما حدث المحاضرة حنتعرف ليش ال n factorial مش n multiplied by n minus 1 factorial. انسى n minus 1 minus 2. ال n factorial مش n multiplied by between brackets n minus 1 factorial.
ايوه صح.
نفس الشيء بس ما وقفت هنا عند ال n minus 1. وين وقفت؟ وقفت عند ال n minus m plus 1. علشان اوصل ال n factorial لازم اضرب هذا بايش؟ بالرقم اللي اقل منه بواحد فاكتوريال. مين الرقم اللي اقل من ال n minus m plus 1 by 1؟ n minus m factorial. ف if you multiply by n minus m factorial this number this becomes n factorial. اطرح اقسم على ال n minus m factorial يطلع عندك بس هذا الجزء. واضح؟ تمام. نعم.
كل واحد له إجابة واحدة بس بالون بس بالفاليو.
يس. لا لحظة شوي، ايش كل واحدة؟
مثلا first.
The first element. Yeah, but how many possibilities do I have? I'm gonna assign it to one element. صح؟
You are counting the possibility.
I'm counting. لأنه I'm counting. I need to count how many functions. So I have n possibilities. I have n images available. صح؟ طيب. For the second element, how many images are available? only n minus 1 لانه خلاص واحد منهم راح يروح لاول element. صح؟ اوكي يا شباب؟ طيب. Okay. Now, what did I leave here? Why I left? There is a big assumption here.
That n is smaller than, larger than m.
That n is larger or equal to m, صح؟ ترى if n was less than m, how many one-to-one functions do I have? Zero. I don't have a single one, right? I don't have a single one. So therefore, here we need to say if n was less than m, there are 0 one-to-one functions. Basically, there are no one-to-one functions, right? Because we will have at least one element in the codomain being the image of two elements in the domain, صح? And that's what we will prove, inshallah, in section 2 when we talk about the pigeonhole principle. Okay, when we talk about the pigeonhole principle. Right. So if n was greater than or equal to m, if n was greater than or equal to m, then the whole thing falls nicely and basically becomes correct. So otherwise, if n is greater than or equal to m, then, and then we continue with our discussion. Okay, and then we continue with our discussion. Do you see when the number of functions, one-to-one functions, will become n factorial? When is it going to become n factorial? When n equal n. مين اللي جاوب من شوية n factorial? If n was equal to m, then you're absolutely correct. It will become n factorial. Okay? It will become n factorial. Okay. طيب. Now, for telephone numbering plans, this is a reading assignment. I'm going to leave it for you. I'm not going to spend time. It's very straightforward, but you have to read it. Okay? It's required. Oh, I need to come back to him. Chapter 2 داخل ولا مو داخل؟
انا قصدي شابتر 5.
وشابتر كل شيء. Oh, I love this. طيب. What is, okay, so let's look at this piece of code. This piece of code consists of nested loops, okay? Consists of nested loops. So you have for I1 equal 1 to N1, and then nested, you have for I2 equal 1 to N2, for I3 equal 1 to N3, and so on and so forth, until you reach for IM equal 1 to NM. Now, if we start with k equals 0 before we go into the nested loop, and inside the body of the innermost loop, we put the statement k equal k plus 1. The value of k will represent what?
The number of iterations.
The number of times this last line here has been executed in the code. صح ولا لا? The value of k will be basically, and this is kind of a measure of the complexity of the algorithm. Okay? This is kind of a measure of the complexity of the algorithm. As I said, you will see it in 353, and you will see even more when things are a little bit more complicated. Okay? But for now, using the product rule and knowing what we know about nested loops, you know that for I1 equal 1, every combination of these will be executed, صح?
Yes.
In I2, it will go from 1 to N2. For each one of those I2, I3 will go. So what will be the value of k after we execute this statement?
N1 into all to NA.
Exactly. So using the product rule, the value k will be N1, N2, N3 multiplied by N. Okay? واضح يا شباب؟ Any question? طيب. Okay. Use the product rule to show that the number of subsets, the number of different subsets of a finite set S is 2 to the power the cardinality of S. Since S is finite, the number of elements in S. How can I use the product rule to prove that? By the way, what is this set called? The set of subsets? ايش هي هذه؟ power set. بتقولوا لي chapter 2 مداخل ها؟ طيب. ايش رايكم؟ Who's going to give me an argument using combinatorics or using counting to count the number of subsets? Mashallah, somebody from section 2, he said it very quickly. And it was basically using, you know, the information that we did in chapter 2. Yes?
3.
Huh?
We can use 3.
3?
Yes.
Why do you want to use a 3?
لأنه بيكون 2 binary 3 بيكون 2 تفرع.
You don't have to. In fact, a subset for each element in the set. What are the conditions or the cases for this element in that subset? It's either or what? For each element in the set. Given any subset, what are the possibilities for this element regarding this subset?
It's n 0 to n.
0 or 1. Inside the subset or outside the subset?
It's inside the subset or outside the subset. صح ولا لا؟ خلاص. So basically, given an arbitrary element AI that belongs to S, given an arbitrary element, there are two cases with respect to the arbitrary ما كتبناها صح هذه the arbitrary subset AI, which are what? Either AI belongs to capital AJ. خلينا نسميها AJ عشان ما يكون في علاقة بين الI بين element والsubsets. AI is either an element of AJ or AI is not an element of AJ. And this is for each element. And this is for each element. Therefore, the total number of subsets, the total number of different subsets is what? Is basically 2 for the first element, multiplied by 2 for the second element, and so on and so forth, multiplied by 2, and this is for the number of elements in S. And that's why this is equal to ايش? 2 to the power, the order of S. Okay? 2 to the power, the size of S, or the cardinality of S. طيب, let me tell you that other student, how did he answer this question very quickly? Do you remember how did we represent sets in the computer?
By bit string.
Huh?
Bit string.
By bit string, صح? We take the universal set, the whole set, اللي هي الset كلها, صح? And we order it, we impose an order, صح? And then we look at the bit string 0 if it does not belong, 1 if it belongs, صح? So now the number of subsets will be equal to the number of what? The number of bit strings of length order S. What is the number of bit strings of length order S? This is what we have done 3-4 slides ago. لما أسألكم how many bit strings of length 7 صح؟ شو قلتوا لي 2 to the power 7 طيب نفس الشيء هنا. And again this is kind of an enumeration صح؟ This is kind of an enumeration, so it's basically very important. طيب, this is regarding. Okay, so let's stop here. Let's stop here, and to reinforce that it's very easy to make mistakes in this chapter. Well, I make mistakes if I don't study, if I don't prepare, I will make also mistakes. I'm really not. Well, I am scaring you, but I'm scaring you for a good reason, not for a bad reason. Okay? Let's watch this video. Okay? Oh, let me first take an attendance. قبل ما تروحوا. Let me take. Well, no. Let's watch the video, but then I will take the attendance because I want to close it. ما نخزن الاتندنس في المحاضرة, ها?
I figure 75% to you, Pop, and 25% divided between the 5 of us. Yida, Crowbar, myself, Tom, and the baby. That makes 5% for each one of us.
Billy, you're cheating yourself. If there's 25% divided among the 5 of you, that's 14% apiece.
Oh, no, listen, Pop. I wouldn't cheat you, you know I wouldn't. Now look here. I'll show you. Rub this out here. And 25 divided by 5 is 5. You see, the 5 won't go into 2. No. But 5 goes into 25 5 times. You see?
You're wrong, Billy. Now, I'm pretty good at this. Now, 5 into 25. 5 won't go into 2.
No.
But 5 goes into 5 once. Now, we didn't use the 2 before, so it's going down here. Now, 5 into 20 goes 4 times. There you are. 5 into 25, 14.
No, Pop. Let me prove it to you now by multiplication. 5 times 5. 5 times 5 is 25.
I'm surprised you're learning. Huh? I'm surprised that you're learning. Now I'll show you. 5 times 14 is 25. 5 times 4 is 20. 5 times 1 is 5. 20 is 5. That's it.
No, Pop. See, look, you're wrong there because I'll prove it to you. We'll put down 5 14s here. 14. There. Now I'll prove to you by addition that 5 14s is not 25. 4, 8, 12, 16, 20,
21, 22, 23, 24, 25. There you are. Now to brush up, Billy. I want to see you boys cheating.
I hope this doesn't happen to you guys. طيب, سبحانك اللهم وبحمدك.